In this question, we're going to try to find the limit as x goes to infinity of the natural log of x plus 1 over x plus 2. So in this case, what we can do is we need to have some rules to compute this limit. Okay, so but basically what we're going to do is we're going to use some famous and a great way to solve this kind of problems. Okay, so the theorem says if we are given that some function f that's continuous and the limit of some g of x as x goes to a is b and f is continuous on b, okay, then the limit of f of g of x, which is f circle g of x. So this is another way of writing it. Okay, so I'm gonna put it in parentheses, so it's a simple way to writing it again. So as x goes to a, so this one is gonna be, since f is continuous, we will enter the limit inside. So the limit as x goes to a of g of x, and we are given this one as one of the premises of this statement. So it's going to be f of b, because f is continuous, so we just compute f of b. We're going to just evaluate, we plug b and we get the result. In our case here, we're gonna let f of x equals ln of x, and g of x is x plus 1 over x plus 2. Okay, so what we can do here is that first we need to compute this limit here. So the limit of g of x as x goes to infinity, so this is just a ratio of x over x, which is 1, okay, ratio of two polynomials. So we have the limit is 1. Now to compute the limit, we just compute the natural log of 1. So the limit of f circle g of x as x goes to infinity is just f of the limit of g of x, which is f of 1. And we know that that's the natural log of 1, which is 0. Because we are given that f in this case is the natural log of x. Okay? So this is one way of doing this kind of problems. Okay? There are other ways to do it, but this is the quickest and the most beautiful and elegant way, is that we need to remember our conditions. So we know that f is continuous on the limit, and the limit of the inner function as x goes to a exists. Okay, so the key is to know how to apply it. You need to know which one is f and which one is g. Okay, and this will tell us that the limit here is 0, and this will end our video.